Hello, welcome back to CTech 243, John Jumpla's tutorials. This is assignment number 5, the base, the height, the side of a parallelogram. So today, I'm going to write 3 functions. We have to write the get values right here. Then we have to write the solve parallelogram, and then we have to write the show values. This is the steps. All he wants it for the first part, the helps. The helps, this thing right here, shows you the outputs and inputs. And of course, type, which it just shows you the code itself of the M file. Here, Meyers was lucky enough to give us the line spaces, so we don't have to go crazy and figure out the spaces for A, B, base, side, height, well, H, G, H, T, perm, and area. 5S, 5S, 9S, 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 9S. And this is the run of the assignment number 5, the first page. He wants this, the help, and then of get values will display the outputs. Help for solve parallelogram will show the inputs and the outputs. And again, help for show values will show you the inputs. The type, of course, like I said before, type shows you the file of the M file. Type again shows you the file, and then type shows you the file, and then the second page is where the fun happens. He wants us to create this. The A, B, base, side, height, perm, area, and then 30, 150, 45, 150, 290, 2,250. And that's the code. And we have to create. So let's go to MatLab. Let's open 7.4. And let's get our first thing. Values. Alright, for our first function right here, we have to get values. Notice in the previous, here get values, it says that you have to write a code for 3 functions. The first one has no inputs and 3 outputs. That's why, as you notice here, there should be no inputs, there's only 3 outputs. If I click on the function, here it's going to display the outputs. Here it's going to display the inputs. The untitled section is where you want to write the name of the file. And of course, this green lines here are just comments. And then you output equals to the input. So here you can write, the equation that you want for the output to equal the input, and then ending the function. So get values. What's your outputs? The outputs is the base, the height, and the area. Base equals input, parentheses, quotation mark, enter vector expression for base, colon, and quotation mark, parentheses, and semicolon. The reason why you have to put this input, this is going to let you, as a user, to able to put the inputs. So you're not have to make a pre-made matrix or pre-made value into the code. This is allowing you to write down into the machine. That's why, henceforth, the input function, or expression, if you may. Because you're allowing to yourself, the user, to input a value or a matrix. So base equals input, enter vector expression for base, height equals input, enter vector expression for height, and A equals input, enter vector expression for acute angle. The quotation mark lets you write down what you want to let the user know what the inputs are. In this case, for the first one, base, height, and acute angle. And to show you, what am I talking about? How would it look? Part of my code. Sum 4. Oh, wait. I'll open up sum 5. Scroll down way in the bottom. All right, here we go. The base, height, and key values. This is how you start the code. Just like he shows us here. In the run of assignment number 5, second page, you enter this, and this is going to allow you to implement your inputs. base height A equals get values, and this is going to allow you to start off and open the function get value. And that's why you're able to see the enter vector expression for base, enter vector expression for height, enter vector expression for cube. And now you can put it in. So let me just do that. Copy and paste. Boom. Just like hit 45, 50, and 30. And as you notice here in the workspace, A is 30, base is 45, and height is 50. Now let's do the second function. Excuse me. Function. The outputs. Area, B, side, perm equals the title of the function, solves underscore parallelogram, inputs, base, heights, and A. Yep. And then you need to assign what you need to the outputs. What's the area is going to be assigned to, what's B is going to be assigned to, what side is going to be assigned to, and what's perm going to be assigned to. So if you go back to here in Meyers packet, it tells you the area is the product of the base and height, meaning it has to be base times height. Don't forget to put the period. In code, you have to put the period. When you're probably in command view, you don't have to put the period. Because if you don't put the period, it's not going to go through the code. B is the supplementary angle to A. So this is a supplementary angle B, meaning that this is B, and this part right here, if there was another line right here under it, is a supplementary, meaning that to get B, you notice that A is here, and B are both supplementary, meaning that if you make a line right here, if there's an angle right here, that will be A. So to get B, it would be B equals 180 minus A. Let me just draw an image for you real quick, since I love figures. Right here. So B and A, those two angles equals 180 since a line is 180. Therefore, to get B, you have to have 180 minus A. That's why in the code, B equals 180 minus A. Now, side. Side is equal to the product of height and the cosecant of angle A. So what I did is just side equals height dot times cosecant, which I wrote CSC, but I believe that the D has to be in there unless the code won't go through. I remember I had trouble trying to find what was cosecant, but I put the D in there. I'm 100% what happens if I don't put the D in there, but for me, I put the D in there, times A. Now, perm. Perm is the sum of the four sides of this figure. So, meaning that there's going to be base and sides. There's going to be two bases and two sides. So 2 times base and 2 times sides. You have to add them up and you get perm. And then if I go back to the other thing, show you how to display it. Type this code up here. My already pre-made code. Area is 2,250. B is 150. Base is 45. Height's 50. Perm is 290. Size 100. Everything is displayed in the workspace. All right. Now the last function. Show values. This is an important part to display the matrix. I'll show you right here. This part. To display the tables, the columns, the rows. Luckily enough for Meyers, he gave us the code of the spaces, and that was a blessing. So we don't have to figure out where the spacing was, you know. So we'll be too intense, and we won't have an hour anguish with this code. So I'm going to thank Meyers for that, because that really was helpful so much. So this right here, fprintf 5, the 5 percentage sign 5s, percentage sign 5s, and the 9 percentage sign 9s. Those are spacings to create this, the A, B, base, side, height, permanent area. This part. So I'll go back to my code, and I wrote that down right here. But before that, you need to write this code, the to show values. But even before that, you have to write what it is. What's it called? Right here, show values. We have no outputs if you notice, because for this part, for the show values, there's no output needed. We're not outputting anything except for the matrix. Therefore, the to show values, you could say, is your output, but not really. We do have inputs though, which is A, B, base, side, height, permanent area. So after writing this down, you need to get the dashes. So luckily for Meyers, you only have to do is just copy, paste this part of the code, and count how many dashes are for each. So for A and B, there was 3 dashes. Base, side, height, perm, there was 4. And for area, there was 5. Now lastly, to finish this code up, you need to do this. And this, as you notice, there's percentage sign 5.0 and percentage sign 9.1. The reason for is this 5 is for the space. But after the decimal point, the 0 is for how many decimal points are going to be. So for this one, there's going to be none. But for 9.1, there's going to be 1 decimal point. Let's go back here. Just like I said, A, B, 30, 150, no decimal points. But base, side, height, permanent area, they do have a decimal point. And again here, no decimal points and decimal points. And of course, you add the decimal points and finish it off with to show, because you're inputting this to show to create the matrix table. Now to finish this bad boy up, just copy this. And boom. And that is how you do assignment number 5. Next time, I will do assignment number 6. But until then, please don't forget to hit the subscribe button, smash that like button, and please don't forget to share with your other fellow engineers. Jay Jumps out.